All right, let's kick off this explainer with a quote from Edsger Dijkstra that completely flips how we look at things. He says, "Computer science is no more about computers than astronomy is about telescopes." I mean, that really redefines the whole field, doesn't it? We aren't just looking at the machines themselves anymore. We're studying the expansion of human capability. The computer is literally just the instrument getting us there. Welcome. Today we're taking a really dense, fascinating chapter on emerging technological trends and translating it into an exploration of our future. We're going to dig into the state-of-the-art tools and systems that are pulling right out of science fiction and actively shaping our daily lives and our digital societies. Think of this as your curated museum tour of tomorrow. Here's our agenda for the explainer. We'll be covering artificial intelligence in action, immersive and altered realities, the age of robotics, making sense of big data, and finally, connecting the Internet of Things. Let's dive right into Section 1, Artificial Intelligence in Action. This is essentially the brain of our digital tomorrow. Before we get bogged down in academic definitions, let's anchor this to something you probably use today. Have you ever wondered how your smartphone map magically guides you to the fastest route, seemingly knowing exactly where the traffic jams are before you even hit them? That is real-time data analysis. That's your phone acting intelligently. That is AI in action, sitting right there in your pocket. So here's the core distinction from the chapter. Artificial intelligence, or AI, is this broad endeavor to simulate natural human intelligence inside machines, giving them cognitive functions like learning and problem solving. But underneath that massive umbrella is machine learning. This is a subsystem where computers use statistical techniques to actually learn from data totally on their own, without us explicitly programming every single rule. They train, they test themselves, and then they make predictions on entirely new, unknown data. It's wild. A really brilliant application of this brainpower is natural language processing, or NLP. You know when you're typing a search query and the engine predicts your exact next word? Or when you casually tell a voice assistant to set an alarm? That's NLP at work. It handles the interaction between humans and computers using our actual spoken languages. It's the tech turning text into speech, speech into text, and even translating languages right on the fly. Moving from the brain to the senses, let's hit Section 2. Immersive and altered realities. This is all about how we actually experience these digital worlds. So if everything we perceive as reality just comes through our human senses, what happens if we feed those senses entirely made-up information? Well, you get virtual reality. VR relies on headsets to create a completely 3D, computer-generated situation that simulates the real world. You are totally immersed in it. Developers are even adding things like sound, smell, and temperature to make the illusion absolutely perfect. It is completely revolutionizing gaming, military training, and even complex medical procedures. But then, on the flip side, we have augmented reality. Imagine looking at a physical shopping mall, but you see digital speech bubbles hovering there, pointing out the food court. AR doesn't replace the real world, it superimposes computer-generated info right on top of it. Location-based AR apps let you point your phone camera at, say, a historical monument and instantly read real-time digital facts floating right over the ancient stones. To boil down the academic distinction here, virtual reality creates an entirely new reality that you physically step into, whereas augmented reality simply adds to or augments your perception of the existing physical world that's already around you. All right, next up is Section 3, the age of robotics. We've talked about the brain and the senses, so now let's look at the muscle executing these tasks. Modern robotics covers just an incredibly wild spectrum right now. A robot, at its core, is just a programmable machine capable of carrying out tasks automatically. But on one end of the spectrum, you have advanced humanoids like Sophia, using AI to actively imitate human facial expressions. And on the other end, we have drones. These unmanned aircraft are following software-controlled flight plans to do everything from high-stakes disaster management to simply dropping a package at your front door a little faster. Which brings us to Section 4, making sense of big data. Every brain and every muscle needs fuel to function, right? Well, get ready for some absolute scale here. 2.5 quintillion. That is the incomprehensible number of bytes of data generated every single day. And thanks to the explosion of smartphone usage and connected devices, that pace is only speeding up. Think about what happens in a mere 60 seconds on the internet. Millions of snaps are created, millions of searches are logged, and thousands of hours of video are watched. This sheer, overwhelming volume is exactly why we call it big data. It's totally unstructured. Your tweets, your photos, your texts, Traditional data processing tools simply cannot handle this level of chaos. So, how do data scientists manage this colossal asset? The chapter breaks it down using the 5 Vs. First, handling the massive volume. Second, keeping up with the rapid velocity of its generation. Third, dealing with the unstructured variety. Fourth is veracity, meaning ensuring the data is actually trustworthy and not just a bunch of noise. And finally, the ultimate goal, discovering value, finding those hidden patterns that are absolutely crucial for scientific research and business decisions. Finally, let's hit Section 5, connecting the Internet of Things. We have all these amazing components, but they need a nervous system to connect them. Enter the Internet of Things, or IoT. Historically, a computer network was exactly that, a network of laptops and servers. But IoT brings everyday devices into the fold. Because modern appliances now have embedded microcontrollers, they can suddenly connect and exchange data. Imagine the surprise of your microwave, your door lock, and your AC unit all chatting with each other on the same intelligent network, while you control the whole shebang remotely from your phone. But the real so what here, the unsung hero making this possible, is likely sitting right in your hand. The evolution of IoT relies heavily on smart sensors. Think about it. When you turn your smartphone sideways to watch a video, the screen automatically rotates, right? That's because it contains an accelerometer tracking its orientation and a gyroscope tracking the twist of your hand. These smart sensors observe the physical world and feed that real-time data straight into the digital network. As we wrap up this explainer, I want to leave you with a really provocative thought drawn straight from the chapter. Look at the device you're using right now. Every tap on that screen, every tilt of a sensor, every voice command you issue is actively generating the big data that fuels artificial intelligence. You aren't just observing the anatomy of tomorrow. Your daily digital activities are literally building it. So the question is, how will your data shape the connected, intelligent network of your future? Thanks for joining me on this tour, and I highly encourage you to keep exploring these amazing trends.